Hi, welcome to my video on the explanation of linear inequalities, two variables on an xy plane. This on the xy plane is called the Cartesian plane, or we could say on the xy axis. A linear inequality in the xy plane is a half plane with or without a boundary line. So what we have here is this graph. I have a line drawn, but notice the line is solid. So if I shade like this, I'm shading a half plane. And this half plane, notice I went out perpendicular to the line. We say this has a half plane above this line. So it's all the points on the line and all the points above it. The boundary line is included in this graph. Or I could also shade on the other side. So this is all the points below this line, including the boundary line. Notice when the boundary line is solid, it's included. When the boundary line is solid, it's included. And this graph is identical to this one, will be, if I shade, again I'm shading above the line, but the boundary line is broken and is not included. And this one, similar to the one above, I'm going to shade below the line and the boundary line is not included. So this one is, you could say, is greater than equal to, because it's solid, all the points on this line are included and the points above. And this half plane or graph here is less than equal to, because it's all the points below the line and including the line equal sign. And this is the half plane above this, so that's a greater than, but there's no equal sign because the line is not included. And this is the half plane below the line, so it's less than, but there's no equal sign because it's not included. It's broken. More examples. State the inequality for each. The boundary line for each of these graphs is y equals x plus 2. So if you say that's 2 right there, if you wish, and that's a 2 y-intercept on all of these graphs, so there's the 2. That means I could put a 1 stroke here if I want, but I'm just indicating that that's the 2. And the slope is 1, which means up 1, right 1. So if this is the boundary line, so I have y, x plus 2. So this graph is these points are above the line, but there's no equal sign because the line is broken. And the boundary line is this. So now I have to fill in this inequality. And these points are below the line, so it's a less than, and the boundary line is solid lines is included, so it's an equal sign. And this boundary line is the same as the other one. And the boundary line, notice the boundary line is broken, so there's no equal sign, but all the points are below, so below is less than with no equal sign. And the boundary line, so notice, well, I'll finish this one out. This is all the points above the line, so above is greater. Notice you're going above in a sense. Notice this one you're going below the line. This one is below the line, down. This one is above the line. And the line is solid, so it's an equal sign. So notice the boundary line is an equal sign because it's, in a sense, even though it's not solid here, the boundary line is always the line with an equal sign that describes the separation from the point above and below in a plane. And let's continue. Practice. State the inequality for each. The boundary line for this one is y equals negative 3x minus 1. So if you think of that, that's your minus 1 right there, right? And your slope is down 3, right 1. So all these lines have the same y-intercept of -1, and it has the same slope. So that means I can go y, -3x minus 1, y, -3x minus 1. And I can do that for each of these. There we go. Now, when I go back, I'm going to fill them in. So the boundary line will have the y, -3x minus 1, placed in all of these. So notice, these are the points that are going down. Notice down below the line. So this is less than, and because the line is solid, that means the points on this line are included in your graph is less than equal to. And this one is all the points above this line, so that's a greater than, but the line is broken, so there's no equal sign. Number 3, again, these are all the points below this line going down, so it's a less than, and there's broken. The boundary line is not included because it's broken, so there's no equal sign. And number 4, these are all the points above the line, so that's a greater than. And the boundary line is solid, so it's equal to. So again, if you think about it, this says all y is less than or equal to -3x minus 1. So this represents all the points below this boundary line and the points on the boundary line. So any point on the boundary line will make this equal to. Any point below it, the y will be less. This left side will always be less than the right side. And what we'll do is explain that using these down right here. A further explanation. Here we go. Notice I have a boundary line, y equals x plus 1. So if I put my boundary line like that, these points are all the points above. You're going above, so that's greater than, and a solid equal to. Now, what about the point F2? The point F is x is 2, y is 4, just approximation. This point is 2, 4, pretend. It's above this line. This point is in this half plane, in all of these points. So this is the inequality that represents all these points above the line and on the line. So now I'm going to show you, let's take this point 2, y is 4, xy, and sub into the inequality. Y is 4, greater than equal to. X is 2. 4 is greater than or equal to 3. So notice when I sub these coordinates of x, y into the inequality is true. That means that this point is in the set where is in the half plane above this line. And let's look at this one. Oh, also, if you take any point down here, let's say we took this point, called it H. If I gave you the coordinates of H and plugged H into here, the coordinates of H would make this false. So just to do that, let's say X is 3, and let's say Y is -1. Just pretend. X is 3, Y is -1. Let's plug H, which is 3, -1, into this equation. I gotta be careful, into the inequality. So if I put a -1 in, and X is 3, -1 is greater than equal to 4. -1 greater than equal to 4 is false. So what does that mean? That means this point is not in this graph. So that's why 2, 4 makes the inequality true, whereas 3, -1 makes the inequality false. So if it's false for H, that means the point's got to be up here, off this half plane. Let's continue. We have, again, the boundary line is y, x plus 1. this plane, all these points here are below, so it's a less than, and the line is solid, so it's less than equal to. So let's look at the point 1, negative 1, C. Let's take the point 1, negative 1. So 1, negative 1 is the point, one of the points that's fitting in this graph. There are millions and millions of points that are here. Notice just so this plane keeps going up and it keeps going down, so it's, I just got a little few at the line going so far, but this line goes on, and there are millions, trillions, infinite number of points. So let's take the point, which is x comma y. Y is negative 1, less than or equal to. X is 1. Negative 1 is less than or equal to 2, and that's true. So that means if this is true, so where I have this less than equal to, and this point makes the inequality true, so this point lies in the graph, the inequality is right, so that's the inequality representing this half plane, or this set of points that I have graphed. And again, the boundary line is the same, y equals x plus 1, and these set of points are above the line, so that's a greater than, but there's no equal sign. Now let me go back up here and take point A just for a second. Let's take point A, which is 1, 2. Point A lies on the line. If point A lies on the line, point A is going to make the inequality or the boundary line true. So if I take y is greater than or equal to x plus 1, y is 2, y is 2, x is 1, 2 greater than or equal to, x is 1, put a 1 in, 2 is greater than or equal to 2. So 2 is greater than or equal to. So this point lies on the line because it is equal to. If it makes it equal to, then the point is part of what we call the equation. So this point 1, 2 makes this equation true. So because it's equal sign, this point lies on the line because 2 equals 2. And let's go down to the bottom one again. And I have the point D. So the point D is negative 2, 3. So this point right here is negative 2, 3. Again, I haven't marked anything off, but you can see that this point is in this graph. So that means that this point is in the graph. That means that this point makes this inequality true. So do I have the inequality correct? Let's see. X, y is 3, greater than or equal to, x is negative 2. So I have y is 3, done. X is negative 2, done, subbed in. 3 is greater than negative 1, true. So this point makes the inequality true, so I know I have the right inequality. Notice this point D is not on the line. There's no equal sign here. Let's continue. So hopefully you're understanding what I'm trying to get at in relation to inequalities lying on a plane, making the inequality true. Practice, pause the video and work each of these out. Here we go. State the points that fit the inequality. So this is the inequality. Y is less than or equal to negative x plus 1. Y equals negative x plus 1 is the boundary line. So there's your boundary line with this inequality in there. So this is the points. Y is less than. Less than is going to the left. Less than means less, below. So what points are below this line? V and K are the points that make this true. And this is a greater than, equal to. Greater than is above the line, so the points are H and I. There's many more points, but I'm just illustrating that these are two that satisfy this inequality. So if you took the coordinates of these points and plugged them in here, it would make it true. If you took these 2 points and had their coordinates and plugged it in this inequality, it would be true. Number 2, What's the, notice it's the same type of line, only this is solid and this is broken. So because this is a broken line, notice there's no equal sign here. So this is y is greater than negative x plus 1. The boundary line, greater than is above the line, so that's a W and an E. These 2 points make this inequality true. And this is less than is below the line, below is here, so that's A and J. Practice. Where is each point in relation to the boundary line? The boundary line, if you had a boundary line of y is less than 3x plus 2, well, let's take x and y. So let's take the boundary line. Y equals 3x plus 2. Y is 5. X is 1. 5 equals 3 plus 2. 5 equals 5. Because 5 equals 5, where is this point? This point is on the boundary line because it's 5 equals 5. Another way to think about this, and I said do it 2 ways. This is one way. Another way is to look at a quick graph. What is the graph of y equals 3x plus 2? Well, let's pretend that that's x is 2 right there. 1, 2, 3, that's a 2. And the slope is 3 over 1, so I'll rise 3, 1, 2, 3, and run 1. So from this point, 1, 2, 3, up 3, right 1. So this is the line that represents the boundary line. Okay, so pretend that's the boundary line. I just dotted it. And where is this point? The point is x is 1, 1, 2, 3, 4, right there. So this point, if you graphed it, that point, 1, 5, is on the line. Okay, let's have a look at this one. And y, 3x plus 2 is the boundary line. We got a 0, and we got a 0. And what happens? We have 0 plus 2, 0, 2. So I put a 0 in for y, 0 in for x. And what do I have? Notice 0 is less than 2. So therefore, that's a less than there. So where is this point? Because 0 is less than 2, this point is above this boundary line. 0 is less than 2. Less than is where? Below. Let's check with a graph to see if we're right. If we have 2, and the slope is 3 over 1, so rise 3, run 1. So there's our boundary line. Could be solid or could be broken. Didn't say. And where's the point 0, 0? There's the point 0, 0. 0, 0 is below the line, down here. So 0 less than 2, this is the less than. 0 less than 2 is below. 0 is less than. So that's the inequality less than, that's below. And we have the boundary line again. Let's write it down. And let's put x, well, this is x and that's y. This is x and that's y. I didn't do that for here. There's 0, 0, x and y. Now y is 4 and x is 0. 4, 0 plus 2, 4 in terms of 2. Where is 4 in relation to 2? 4 is greater than 2, so therefore this is a greater. So where is this point? This point is above. Because 4 is greater than 2, this inequality has this greater than sign, therefore it's above. And let's check with a graph. Again, here we go. Remember, okay, just that's x and that's y axis. That's x and that's y. X is, sorry, the y-intercept is 2, and we rise 3 and run 1. So we got this boundary line again, the same boundary line we had in these two. Now, the point x is 0, y is 4. There's the point right there. That's the point 0, 4 in relation to this boundary line. And this point is where? Above the line. So there's two ways that you can do. You can take the point and plug it in. If the point says greater than, then it's going to be greater than inequality, lying above the line. So that's a little explanation going through an inequality is a half plane, including the boundary line or not including the boundary line. So the boundary line is very important, and you're above or below. If you like my video, click the like button, the subscribe button, and the notification bell, because there are more videos coming. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. And that's the content that I have on my YouTube channel. What's outlined on www.mathfullyexplained.com is the content on my YouTube channel. Thank you very much for viewing my video. Bye-bye.